Welcome to Automotive World. Hello everyone, I'm Martin Carl, I'm the editor of Automotive World, and I'll be moderating this session on swarm-based open architecture. On the panel today we have Sambit Patnaik, who will talk us through the use of swarm-based open architecture software in the development of the connected vehicle. A little bit of background: on-demand, shared and personalized, that's the general expectation of the next generation mobility experience. However, catering for future demand in a timely and efficient manner requires scalable, secure and personalized in-vehicle software. That software needs to be customizable with the ability to easily add, upgrade and swap the components in the software that is likely to play a huge role in ensuring seamless future mobility platforms and vehicles. For this, we should consider an open approach to vehicle software architecture. So believes Sambit Patnaik, technical architect at Elektrobit, who will today discuss how swarm-based open architecture for in-vehicle infotainment systems takes the industry one step closer to this modular and scalable mobility future. We'll have a presentation followed by the opportunity to put questions to Sambit. If you'd like to ask a question, please type it into the Q&A box on your screen and we'll address as many relevant questions as possible. We'll also make slides and a recording of the event available, and we'll send you an email to let you know how and when you can access those. That's all you're going to hear from me. I'm going to hand over to Sambit now for how does swarm-based open architecture approach shape the future of mobility. Sambit, over to you.
Thank you, Martin, for the brief introduction. Hello, everyone. So I'm going to cover this concept on swarm-based open architecture for in-vehicle infotainment system. So as part of this concept presentation, I'm going to cover the trends, innovations, and technologies that will drive our future mobility. Next, I will go into the motivation for swarm-based open architecture. So what is the motivating factor for going with the swarm-based open architecture? Why do we have to think of a different architecture for in-vehicle infotainment systems? Then I will cover upon the principles on which this swarm-based open architecture is based on and a high-level block diagram of this. Then I'll cover the Docker and the advantages of Docker container, because this is the crux of the whole architecture. So at the heart of this architecture lies the Docker and what benefit it brings to this architecture and how we can realize this architecture with the Docker and Docker container. And last slide would be the key advantages of swarm-based architecture, and followed with the question and answer session. So let's get started. So trends, innovations, and technologies are the ones that are going to drive our future vehicle mobility. So from now on, 5 or 10 years down the line, we are going to see intelligent cars. So when I talk about intelligent cars, it's going to know who we are or who the person steps into the car. So it acts as a friend, it acts as a personal assistant, it knows that where am I driving, and it starts giving me recommendations, suggestions. So it acts as a personal assistant to me. And it is backed by deep learning and AI and machine learning, so that because it needs a lot of data if it has to recommend or predict something. So that way it becomes intelligent. Then it's going to be future-proof car. So when I say future-proof, the car should be able to upgrade itself. It should be updatable. The architecture has to be flexible enough so that new features can be updated regularly. And the variant is reduced, as in the car will have no different car models, but one car, but with the software you can update the vehicle. So more and more software features are going to come inside the car as and when they are available in the market. So your vehicle should be able to update via softwares. And then coming to shared and personalized car. So the car will not be going to be a thing that a personal or an individual owns. It is going to be shared. It's going to be on demand. So already this has already started in market where car sharing is going on, but with the car sharing comes a challenge, like we need to customize according to the user who steps inside the car. So if I step into a car, I want that my taste, my preferences are customized. I mean, the car infotainment is customized according to my likings. The ambient temperature, ambient lightings, the seat settings all gets customized when I step into a car. So in that way, it's personalized. So all my personal preferences, the music preferences, or my preferences of the destinations gets customized. Then would be the connected car. So the car is going to be the central hub from where I can connect to office, I can connect to home. So I can bring in any smart devices inside the car and it seamlessly gets connected to it so that I can access everything. So these are the four broad areas that are going to drive the future of our vehicle, the infotainment system. So with that, I move on to the next slide, which talks about the motivation for this swarm-based open architecture. So why do we have to think of a swarm-based open architecture? So if you see this diagram, this shows the x-axis shows you the services, and the y-axis is the vehicle variants. So you have entry, high multi-seat. So entry is the base variant, and then high is where you have some more features that come in. And then multi-seat is like you have multiple displays. You have rear seat entertainment, you have center stack displays, then you have other displays even on the window panes. So it gives full of displays everywhere. And then if we move on the x-axis to other services, the box, the blue box, which is highlighting the base services, are the ones which are currently available in the car. So you see radio, you see phones, you see navigation. So these are some of the features which are already there in the existing vehicle, and they are more or less running on the local hardware. So they are completely on the head unit which is there inside the car, and most of the data are driven from there. But as and when you move towards the right side, you see features like in-car office, you see car commerce, traffic, map data, predictive learning. So these are some of the services or the features which needs cloud services. Without that, we cannot realize these features inside the car. So as and when we move on to the cloud services, we need an architecture flexible enough so that these features can be brought in into the car on the go. So we do not have to wait for a software update of the entire head unit, rather it has to be on the go. So as and when the feature comes into the market or when there is a new update for a given feature, it must be downloaded or it must be installed onto the vehicle head unit and the user experiences that. So that's where we have to think of an architecture which is not monolithic, which has to be flexible, which has to be open, and which enables us that is agile delivery of the features onto the head unit. So let's look into what are the principles that this swarm-based open architecture is based on. The very first thing is the service-oriented architecture forms the base. Yes, so I cannot realize those features, cloud-based services on the head unit if it is a monolithic system. So it has to be updated frequently, and if it is a monolithic system, I have to always go for a complete software update of the entire head unit, and that's not going to be frequent. So we have to break down the features into different multiple services, and those services can be updated regularly as and when needed. The second is the service communicate with each other over well-defined interfaces and protocols. So if we have multiple services running on the head unit, and there are some services also running in the backend, there has to be a well-defined interfaces through which they communicate with each other. The protocol has to be defined in such a way that a particular service version running on the cloud or on the head unit must be compatible with the services that are available in the cloud, in the backend. So we need to have that kind of a defined interfaces. Then coming to augmented computing to support resource intensive or distributed use case. So I'm going to, so here this architecture is going to use the capabilities of the cloud. So the cloud has a lot of storage, lot of CPUs, lot of computing power. So we are going to augment that cloud power into the head unit. So if there is any service that needs high memory, heavy CPU usage or CPU power to compute, so those services are offloaded to the cloud backend and it's run there and we get the data back to the head unit. So basically we are augmenting the cloud capabilities onto the head unit here. Then coming to services are updated regularly and fail alone and itself recover itself. So services must have the capability that if there are not enough resources available for it to run, it shuts down and again recovers itself or starts again itself whenever the resources are available. Then last is the services running on multiple nodes, head unit, cloud, user devices collaborate to create context and provide intuitive user experience. So here in this architecture, in the next slide I'll cover, there are three nodes basically, the head unit node, the cloud backend, and the user devices, which are the smartphones and smartwatches. So these are the different nodes that together talk to each other and create a context, because each of the node has a lot of data in it. And when we have to create a context out of it, all of them have to talk to each other to provide that kind of a user experience. Now let's move on to the high level block diagram of this architecture. So I'll start off with the head unit. So the head unit is the one that is inside the car, which provides us with different features. And the basic architecture of it is that we have a hardware, we have an operating system, then the middleware with the applications. And here we have these green boxes, which are services 1, 2, 3, and N services. So those are basically the microservices which are running on Docker container. And the Docker is the one that is in the middleware layer. So that's the heart of this whole system to work on. And then we have the UI layer. So now I'll move on to the cloud backend. So there are some of the components which needs some detailed explanation. I'll start with the Docker part. So in the cloud also we have a Docker which hosts different services in a container. Those are backend services. So these backend services are going to provide the functionality to the head unit. So these backend services are the end user focus services. And the services that are running in the head unit are nothing but the client microservices, which will be downloaded onto the head unit to access these backend services. And the Docker, this Docker means it's a Docker daemon, basically, which is running on the cloud backend. This Docker daemon talks to the Docker that is running on the head unit, and they form a swarm cluster. So a swarm terminology in Docker is multiple Docker daemons collaborate with each other to form a cluster, and they manage different services that are hosted on different nodes. So I'll touch upon the Docker containers and the swarm mode a little bit detail on the next slide. Now I'll move on to the next blocks, like we have third-party services in the cloud backend. So these third-party services are nothing but the services like online music services like Spotify. Then we have map services, online map services, like here provides online map data. And we have other third-party services which are the content providers basically. And those are the ones that will provide us the content from the backend. Coming to the container repository and the CI/CD pipeline. So container repository will store the different Docker images which gets downloaded and installed in the head unit. The CI/CD pipeline will enable the continuous integration and continuous deployment pipeline. So this pipeline is needed for the development of any services. So if I am a developer, I want to develop a service which I want to push it to a particular version of the head unit, I will use the CI/CD pipeline to develop it, test it, package it, and then deploy it to the container repository. Then coming to the deployment and lifecycle management, this block is very important because as it is a service-oriented architecture, we have a lot of different software services that will be developed, and we have a lot of different software versions that are running on different head units, on different cars. So we need to really understand that which particular service version is compatible on which particular software running on the car, and that's where we need a deployment management and the lifecycle management. So we have a registry where we will have different services that are developed, and those services which are compatible with a particular head unit software have to be stored here, and that kind of a deployment management has to be done. And if a particular service, there is a new updated version has come in, then we have to remove the older services which are no longer in use. And then we have a development environment block. So this development environment is the virtual environment which will be accessible to the developers who want to develop a service. So I want to develop a service, so I need to know the interfaces that are needed to develop the services. And this development environment provides me a virtual environment of the vehicle head unit environment, which provides me the APIs or different interfaces with which I can know that, okay, what kind of services I need to develop. And it provides me an environment where I can test my service and then I can push it for the production. Then coming to the user devices, so which here I have just shown to complete the entire ecosystem. It's a smartphone and the smartwatches. So those are very important because they have a lot of personalized data in it, and we need those data also to create a context or to create a user experience in this case. So those are the devices also that connects to the head unit and also to the backend to provide that useful data. So this slide talks about Docker, and this highlights the Docker, which is a part of the head unit. So a Docker is a open source project that automates the deployment of software inside a container and uses the operating system level virtualization. So Docker uses Linux kernel, C group, and namespace features and union file system. So it is lightweight, as in it doesn't need a new OS to start it. It doesn't need a new OS. It can run on on the host OS, host Linux kernel. So this OS level virtualization is much lightweight. It is one level above hypervisor. So hypervisor provides you a hardware level abstraction, but this provides an operating system level virtualization. So Linux has this feature, and Docker uses those features like C groups and namespaces to realize this. So C groups, people who are new about this concept, C groups provide the resource limitation, it restricts the amount of memory or CPU that a process can use, and namespaces provide isolation of the process view of the operating environment, starting from the process trees, the user IDs, and the networks and the file systems. So that kind of abstraction it provides. So we are using, Docker is using those features to realize, and on top of that, it provides some of the tools that can be used to orchestrate different Docker containers. So these are some of the features that Docker provides, a Docker container offers. So it's a logical packaging mechanism where applications can be abstracted from the environment in which they were actually run. So it provides a sandbox, it provides a logical packaging where all the dependencies, libraries that are needed for a process to run is packaged together and isolated, and it also is assigned a resource which will be used when it runs. In that way, it is completely isolated and segregated. Then the containers have less overhead and enables more efficient uses of underlying system. Yes, container is unlike virtual machines or host OS, it's just another process in the same Linux operating system in the host OS. It doesn't spawn a new OS, rather it just starts a process in a container. So it is much faster and much more efficient. Allows users to package an application with all its dependencies into standardized units. So it provides a standardization environment when you have all the dependencies, configurations, libraries packaged together. Then Docker container ensures consistency across multiple development platforms and release cycles, thereby standardizing your environment. Yeah, and I'll go through the Docker Swarm concept a little bit in this slide. So Docker Swarm, as I said, there are multiple Docker daemons that can combine to form a cluster, and they manage multiple Docker containers. So think of a use case where I have a cloud where I have a Docker daemon running on, and then I have a fleet of vehicle cars running Docker in it. So I can have this Docker daemon and the Docker daemons on the head unit to form a cluster where this Docker daemon running on the cloud can be a manager, and the Docker daemons running on each of the head units form workers. So they form together a cluster, and different services that are running in the backend in the cloud and the services running on the head unit can be managed. So that's where this Docker Swarm concept comes in. And this Docker Swarm feature is available from Docker version 1.12. Before that, we had only the Docker which provides just a container management on a single host. Now moving on to next slide, which talks about the advantages of Docker container. So in the head unit, we have different services which I have highlighted, and those are the Docker containers. So each of the container runs a particular process, and this is a microservice which connects to the backend through either REST-based communication, HTTP communication, and it gets the data from the backend. So the Docker which is running on the head unit manages these Docker containers. So very first is the compatibility and maintainability. So with this Docker container, the problem of it works on my system is finished once and for all, because it provides a standardized environment It packages all its dependencies and libraries, as I have mentioned, and it works the same irrespective of the environment where you run it, whether it would be your personal laptop or it is on a private cloud or on a public cloud. It runs the same because it has all the required dependencies needed to run a particular program. Then coming to simplicity and faster configuration, Docker containers makes things simple, and once you build a Docker container image, that image can be used at different stages of development process. So it provides the developer a standardized image, a standardized environment where they can build upon and they can build new features on it. And they can use that image as a base image and they can build upon the feature and package it and deploy it. Rapid deployment, yes, reduces the deployment to seconds because it's just another process that you have to create. It's just another process, starting a new process, as compared to your virtual machines where we have to start a completely new, boot a new OS. So it is way faster compared to a virtual machines. Then coming to continuous deployment and testing, Docker container supports CI/CD, so it can be versioned. It can once you create an image, that image can be used at different phases in the deployment process. So the developer deploys a particular version of the container image, runs it. If there are any issues or bugs, then the developer fixes those in their development environment and just redeploys the same container onto the production. Then coming to multi-cloud platform. So nowadays, most of the major cloud providers like Amazon Web Services, Microsoft Azure, Google Compute platforms, they have Docker support in them. So that brings the biggest advantage of Docker, that it is portable. So there is a Docker container which runs on Google Cloud platform, and it runs the same if it is moved to Amazon Web Service or Microsoft Azure, if the Docker support is there. Then coming to security and isolation, so they are one of the biggest advantages of using Docker containers. So Docker containers are secure because they get their own resources. The processes running in one container cannot look into the process running in another container. In that way, it's completely isolated from each other. And each Docker container receives its own CPU, its own memory, its own file system. So in that way, it is completely isolated. And the isolation is also that it provides an isolated environment. And if a particular Docker container runs on a system and you want to remove that container, you simply delete that container. It doesn't leave any residues on the host operating system. So it doesn't leave any temporary files. It doesn't leave any configurations. So in that way, it is completely isolated. So these are the key advantages of Docker container, which enables us to think of this architecture where these Docker containers can be deployed onto the head unit without impacting the normal operation of other functions in the head unit. So with that, I go with the advantages of Swarm-based architecture. The very first is it provides a sandbox environment inside head unit to run services that will shield and protect the normal head unit function. Yes, because Docker containers are isolated and secured, so they provide that kind of a sandboxing environment. Enables end-user focused services accessible seamlessly in various contexts or via various devices. So these end-user focused services are the ones that will be running in the cloud backend, and we have microservice-based containers which are deployed in the head unit, and they seamlessly talk to each other. So user is completely abstracted off from where the data comes. It is completely abstracted, and it comes from the cloud, and it comes from which cloud, that also is completely abstracted. Enable agile delivery of new features to head unit, decoupled from standard release cycles of underlying platform. This is very important because the head unit software, the complete software package, release cycles happen like once in a year or maybe once in a 6 months, but we do not have to wait that long period to get a new feature. The user needs a feature whenever it comes, whenever it is available in the market. So in that way, the architecture is flexible, and it decouples it from the release cycles. So I get a new update. Also, it can be in every 5 days or in every 10 days, I get a new update or new version of a particular service. Enable seamless handover between context. So when I say about seamless handover between different contexts, it is about multiple different services that are running in the head unit and the cloud backend when they are talking to each other. So if a particular service needs a cloud capabilities, it is offloaded to the cloud, and that's completely seamless. The user is completely abstracted of it. Cloud backend host services for deployment of microservice-based end-user subscription. So yes, this microservice deployment happens based on end-user subscription. So the user subscribes to a particular service, and that gets installed, that gets downloaded and installed in the head unit. And if the user unsubscribes it, then it gets uninstalled and doesn't leave any residues because it's running in a Docker container. The cloud backend will provide development toolchains to build those microservices. Yes, the development toolchains and the development environment, which I have highlighted in the block diagram, provides that kind of environment to the developer to create such services. And the last, the CI/CD pipeline ensures continuous building changes delivered by development teams, doing integration tests and updating content to the central container repository. So CI/CD pipeline gives us that flexibility where a developer can develop a given service, test it, and then deploy it to the production server, production environment using the continuous integration and deployment pipeline. So these are the advantages that we get if we have this swarm-based architecture. So with that, I open up for the question and answer session. I give it to Martin.
Great. Thank you very much. Thanks for the presentation, for the slides as well, and for sharing that insight with us. We do have an opportunity to put some questions to Sambit now. So if you have a question, please type it into the Q&A box on your screen. I mean, I think you've summarized this fairly succinctly, but perhaps you can just give us a few more lines that weren't in your presentation about how this architecture helps developers.
Yes. So to developers, this architecture provides a development environment in the cloud, which is a virtual environment, and it also has a CI/CD pipeline with which a developer can develop a particular feature, given services, and then test it and package it and then deploy it. So in that way, a developer get to know, and it gets that flexibility of developing a service and testing it so that it runs the same if it is deployed on the car or on the vehicle. So in that way, it provides that kind of a flexibility, that kind of a agile mechanism where the developer can develop any service and test and deploy it. So that's one of the biggest advantages of using this Docker infrastructure and Docker containers.
All right. This particular architecture obviously has benefits. You showed them at the end, but for the end user, what are the benefits?
Yes, for end user, the benefit is that the end user can subscribe to a particular service and unsubscribe at his will. So if he subscribes to a particular service, like he is interested in having a Spotify as one of the online service provider into the head unit, he subscribes to it and it gets downloaded onto the head unit, which connects to the Spotify backend and starts to fetch the online music content. And if he doesn't want that service, he just have to unregister it, and that particular microservice gets uninstalled from the head unit without leaving any kind of configurations or any kind of residues on the host operating system, host head unit.
Okay, so how do you make sure that services installed on the vehicle head unit don't then impact other system functionalities?
Yes, so that's one of the biggest advantages that Docker environment and Docker provides, that it provides isolation, it provides security. So that's what I have covered as part of the advantages of Docker container. So a Docker container is completely isolated because it uses this namespace and C groups feature of Linux kernel, which provides that resource isolation features. And so it gets its own resources that it has to use, and it cannot use the system's available resources, which typically leads to performance degradation. So whatever resources allocated to a particular service will be used by a Docker container, and that's what will be also specified when this particular service would be developed by the developer, so when it's written. So in that way, it is completely isolated and secured. And it also provides that a sandboxing where it cannot look into the other processes running in different containers. So it's completely segregated. So the Docker containers get completely different resources, and it gets its own network stack. It gets its own CPU. It gets its own file system for any operation. In that way, it is completely secured.
I'm interested to know a little bit more about where this is used, and by that I mean, is it used within particular departments in automakers or in tier one suppliers, or is it further down the line?
Yes, so this architecture can be used by tier ones in developing head unit software. It can also be used by OEMs who are into the software development of head units. So they can have this kind of architecture which brings that kind of agility and flexibility in the architecture, so that any new features, any end user features which gets into the market can be rolled out easily to the head unit without waiting for a complete head unit reflashing, either over the flashing over the air OTA update or through any other means. So in that way, they can have this architecture, this concept as the architecture in their head unit to provide this kind of flexible feature rollouts.
Okay, we've got a question for somebody in the audience who says they think you mentioned it syncs with phones, Android devices, and so on. Could you talk, therefore, a little bit about the security, data security, and so on that comes with this, please?
Yes, so the data security part is, so when we are talking about the Docker containers which are downloaded onto the head unit, so we have to make sure that they do not send some data to the cloud which are not secure or which cannot be offloaded to the cloud. It has to be completely within the head unit. So because user data are secured, and we cannot just make all the user data sent to the backend to the public cloud. So in that way, we have to make sure that when we have a Docker container running in the head unit, they do not use any of those data to offload to the backend. They do that data and use it for the processing within the head unit. So in that way, data security is maintained, and that Docker container ensures that data doesn't leave that container. It only is processed within that container.
Does the use of Docker increase the need for additional resources in the head unit, for example, RAM?
So one of the feature of Docker is that it uses union file system. So this union file system is a resource managing mechanism which uses copy on write. So in that way, so if you do not have a union file system, so there is a Docker image which uses 200 MB, and you spawn 5 different processes or 5 different instances of the container from the same image, then it would take 1 GB of the disk space as in the memory. But if you have a union file system, which is in the case of Docker, it is just the same 200 MB, a little bit more than 200 MB, but it's not going to be 1 GB. So it's a copy on write. So the memory that is allocated will not be copied unless and until there is a write operation on it. So in that case, it is shared. The memory that it uses will be shared across the containers, and it isolates the amount of memory only when a particular container tries to write something to it. So there will be a different amount of memory that gets allocated to that particular container. So in that way, I would say that it is much efficient for the memory usage, these Docker containers.
Okay, Okay, somebody in the audience would like to know, how would you compare this with an IoT edge approach?
Okay, so IoT edge approach is mostly like you do the computation, you push the computation to the edge node where you try to uh, compute something on the edge because data is available there and you cannot send that data to the cloud because of some security. So uh, here it is little different. Here we have to offload the services to the backend so that we get more of computation power of the cloud so that the processing cannot be done in edge node. We offload it to the cloud so that it gets done in the backend and then get the data back to the head unit. So this is something which is just the opposite of edge computation.
Does the Docker infrastructure need unique containers for individual head units, or does a container infrastructure have the ability to support multiple head units?
It can support multiple head units, as in if I think from the Docker Swarm perspective, then we can have a Docker daemon, which is the manager, which is sitting in the cloud, and we have multiple Docker containers which are running on different head units, and those are managed by the manager, which is sitting in the backend. So we have multiple containers running on different head units, and they are managed by a single Docker daemon. So that's possible. So if I have to roll out a particular update to a given container running on different head unit, then I can do that in one shot in this kind of architecture where it pushes the update to all those head units where that particular version of the container is running.
Okay. Are there any major projects that you can refer to either by name or, if not by name, then perhaps by some sort of general description that have successfully used Swarm like this?
So to my knowledge, I can say that Docker containers have been used by Spotify, which heavily uses this Docker. But the Swarm architecture, I don't know which automotive have used currently. At least I haven't heard of a company who has completely rolled out in the market with this kind of architecture as of now.
Okay, I'm interested as well in learning a bit more about the fact that this is open source. So can you talk broadly about the advantages and disadvantages or challenges, perhaps, of using open source and why you would use open source in this case?
Well, open source in this case means it's open source because it doesn't have a license, definitely. So in that case, I can have this architecture in my head unit architecture without any cost or without any money associated and monetary associated with the rollout of each individual head units. So in that way, it is if cost efficient. The other benefit is that there are other orchestration frameworks, container orchestration frameworks, which are open source as well, but they have like Kubernetes, but they have their own advantages and disadvantages. So we have to really see that which particular technology best suits your requirement. So I would say the Docker Swarm is one container orchestration technology which is open source. Even we have Kubernetes, which comes from the Google, and then we have to see which suits your best the requirements.
Okay, great. Well, we've taken all the audience questions, and I think that brings us then to the end of the session. Thank you very much for sharing your insight with us today. As usual, we'll make slides and an on-demand recording of the webinar available for you to access at your leisure. We'll send you an email to let you know how and when you can access those. And with that, I'd like to thank Sambit and Elektrobit, and we'll see you at the next Automotive World webinar. Thank you very much.
Okay.
And goodbye.
Thank you, everyone. Thank you.